Lesson 2.3, Solving Multi-Step Equations. In this video, you will learn how to solve equations involving more than one operation and solve equations involving consecutive integers. Vocabulary for this section includes multi-step equation, consecutive integers, and number theory. Okay. So first thing we want to understand about solving a multi-step equation is how to unwrap something per se. So if we're looking at this here, what are the order of operations that we would do to Q? First thing we would do to Q, following order of operations, PEMDAS, right, is we would multiply by 2. And then the second thing we would do is add 11. And then by the time we're done, we get 3. So if I want to undo this, I'm going to do the opposite operations in the reverse order. So if you think about packing up a box, you put it in the box first, and then you wrap it, and you put a ribbon on it. But when you unwrap it, you're going to first take off the ribbon, and then you're going to unwrap the box, and then you're going to open it. Okay? So it's going to be the same thing. So we're doing the opposite in the opposite order. So we're going to be going this way, doing the opposite operation. So the opposite of adding 11 is subtracting 11. And the opposite of multiplying by 2 is dividing by 2. So to solve this, 2q plus 11 equals 3. First thing we're going to do is subtract 11. So when we do that, we get 2q equals negative 8. And we divide both sides by q then, and we get by 2, and we get negative 4. So q is negative 4. So first we subtracted 11, that was first, and then we divided by 2. That was the second thing we did. Okay, and that solved our equation. Okay, so if we're looking at this, what are the things that are we doing to k first? First, we're adding 9, and then after that, we divide by 12. So if we're solving this, we're going to go the opposite direction and doing the opposite operations. So multiply by 12, and then subtract 9. So if I have k plus 9 over 12 equals negative 2, first thing I'm going to do is multiply both sides by 12. So over here, those 12s cancel. So I get k plus 9 equals negative 24. And then the second thing I said to do was to subtract 9. So when I do that, I get k equals negative 33. Okay. We can use this with a word problem as well. So Susan had a $10 coupon for the purchase of an item. She bought a coat that was half its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Write an equation for the problem, then solve the equation. Okay, so the coupon is applied last. So she bought a coat that was half its original price. So if X is its original price, it was half of that. And then she had a $10 coupon, so that takes off $10. Okay, and all in all, she ended up spending $125. Okay, so doing the same thing, first thing you would do is you would multiply to x, you would multiply it by 1/2, and then you would subtract 10 if you're following order of operations here. So to figure out what x is, we're going to go the opposite order with the opposite operations. So plus 10 and divided by 1/2, or that's the same thing as times 2. Okay, so if I add 10 to both sides, I end up getting 1/2 x equals 135. So if I want to know what x is, I'm going to multiply now both sides by 2, and I get x equals 270. So the original price of the coat was $270. Okay, so we're going to do a brief look at some number theory. So in order to do this, we just want to understand some vocabulary. So consecutive integers are integers that come in counting order. So for example, -2, -1, 0, 1. They're just numbers that come right after each other. Okay, so example, I could also say 6, 7, 8. Those are consecutive integers. They're integers that are one right after the other. Okay, and then if you have consecutive even integers, that's just going to be looking at even numbers. So if we have -2, 0, 2, 4, it's all even numbers, one right after another. It's not skipping them. So if I were to say 2, 6, those are not consecutive even integers because I skipped over 4. If I had said 2, 4, 6, then I could say yes, those are consecutive even. And it's going to be the same idea with odd. So -1, 1, -3, 5, those are all odd integers and they're one right after another. Okay, so if we want to use this information to write an equation for the problem below and then solve the equation and answer the problem. So we want to find 3 consecutive odd integers whose sum is 57. So let's say that my first odd integer is x, okay? And there's sum, so it means we're going to be adding them up. So there's 3 of them, and they're going to all add to 57. So if the first one is x, odd integers, if I go from 1 to 3, I went up 2. Or if I went from 7 to 9, I went up 2. So every time you go from one odd integer to the next, it increases by 2. So if this is x, then we can say this one is x plus 2. And then if it goes up another 2, we can say this one is x plus 4. So in order to solve this, I can combine any like terms. So I have x, x, and x, so a total of 3 x's. And then I have this 2 and this 4 that can be called 6 equals 57. So if I'm trying to solve this, again, doing the opposite order of what I would do to x. So to figure out what, if I was doing order of operations over here, I would do x times 3 and then add 6. So I'm going to do the opposite in the opposite direction. So I'm going to subtract 6 first. So I get 3x equals 51. And if I divide then by 3, I'm going to get, divided by 3, it goes once there, 21, 7 times. So x equals 17. And that is it for this section. So I will scroll through the extra problems now, and if you feel like you've got it, then you may stop here.